You might think of volcanoes as exotic mountains spewing lava and smoke in remote parts of the world, something out of a movie or a geography textbook. But what if we told you that beneath the surface of the Earth lie sleeping giants that could, with almost no warning, change the course of civilization itself? These are no ordinary volcanoes. These are supervolcanoes, massive, brooding beasts with the power to darken skies, cool the planet, and bring global chaos. And while most people go about their daily lives unaware, a small group of scientists are quietly sounding the alarm, urging humanity to pay attention. Because some of these supervolcanoes, they're waking up. Volcanoes are among Earth's most awe-inspiring and destructive forces. They've shaped continents, birthed islands, and ended civilizations. Their eruptions are often violent, yes, but the rarest, most dangerous ones are those that explode not in a fiery cone, but in a colossal underground burst that sends shockwaves around the world. These events aren't just regional disasters. They're planetary. They rewrite climate systems. They collapse economies. They reduce global food production. And they've happened before. To understand the magnitude of what we're talking about, consider the Volcanic Explosivity Index, or VEI. It's a logarithmic scale scientists use to measure the size of eruptions, kind of like the Richter scale for earthquakes. It ranges from VEI 0, the gentle ooze of Hawaiian lava, to VEI 8, the maximum, and the realm of supervolcanoes. Each step on the VEI scale is 10 times more powerful than the one before. That means a VEI 5 eruption is already 10 times more explosive than a VEI 4. By the time we get to VEI 8, we're talking about eruptions that release over 1,000 cubic kilometers of ash, lava, and gas into the atmosphere. That's enough to bury entire countries. Let's start with a more familiar eruption for comparison. In 1980, Mount St. Helens in Washington state blew apart with a VEI 5 rating. That explosion killed 57 people, flattened 230 square miles of forest, and sent ash drifting over 11 states. But it's a baby compared to what a supervolcano can do. Go back to 1991, to Mount Pinatubo in the Philippines, a VEI 6 eruption. It was 10 times more powerful than Mount St. Helens and caused global temperatures to drop by 0.5 degrees Celsius for 2 years. The eruption sent 20 million tons of sulfur dioxide into the stratosphere, reflecting sunlight and dimming the Earth. But again, even that was still short of what we classify as a supereruption. The 1815 eruption of Mount Tambora in Indonesia, a VEI 7, was one of the most powerful in recorded history. It killed over 70,000 people and launched enough ash into the atmosphere to trigger what became known as the year without a summer. Crops failed across Europe and North America. Snow fell in June. Prices for grain and oats skyrocketed. Famines broke out. Mary Shelley stuck indoors during the dark summer, wrote Frankenstein. That's the kind of cascading effect a volcano can have. But Tambora wasn't a supervolcano either. It was powerful, yes. Civilization-altering, definitely. But still not the largest. To get to true supervolcano status, we need to look even deeper into Earth's past. One of the most colossal super-eruptions occurred about 74,000 years ago at Lake Toba in Sumatra, Indonesia. That was a VEI 8 eruption, over 2,800 cubic kilometers of ejecta, enough to cover the United States in a foot of ash. The blast created a lake that today spans over 100 kilometers. It was so powerful that it may have triggered a global volcanic winter, lasting up to a decade. The sun was dimmed, temperatures plummeted, and evidence suggests the human population dropped drastically, possibly to just a few thousand breeding individuals. This is known as the Toba catastrophe hypothesis, a theory that suggests our species came perilously close to extinction because of a single volcanic event. But while the idea of a population bottleneck remains debated among anthropologists, the environmental impacts of Toba are widely accepted. Ice cores from Greenland and Antarctica show clear signs of a sudden temperature drop. Ash from the eruption has been found as far as South Africa and the Indian Ocean. What's most alarming isn't just how big the eruption was, but that it wasn't a one-off. The Toba caldera has erupted multiple times, and geologists believe it's only a matter of time before it awakens again. Then there's Lake Taupo in New Zealand. Around 26,000 years ago, it too experienced a VEI-8 eruption that tore apart the central North Island and created what is now the country's largest lake. The eruption hurled ash across the South Pacific and was large enough to have noticeable effects on global climate. Taupo has erupted many times, and while it lies quiet now, it remains under constant surveillance. Supervolcanoes don't always look like the tall, conical peaks we typically associate with eruptions. Many are hidden in plain sight as massive calderas, giant collapsed depressions formed when a massive underground magma chamber empties so rapidly the ground above it collapses in. These calderas can be dozens of kilometers wide. You could drive across one and not even realize you're in the middle of a volcano. Which brings us to one of the most infamous supervolcanoes of them all, Yellowstone. Located mostly in Wyoming, the Yellowstone caldera is part of a vast volcanic system that has erupted cataclysmically 3 times in the last 2.1 million years. The most recent super eruption, 640,000 years ago, created the current caldera and blanketed the western United States in ash. Traces of that ash have been found as far east as Louisiana. If that eruption were to happen today, cities like Denver, Salt Lake City, and Billings would be buried. The effects would ripple through agriculture, aviation, and infrastructure nationwide. And that's just the immediate aftermath. Yet Yellowstone is not extinct. It's still active, a massive magma chamber lurking beneath the surface, slowly shifting, emitting gases, and occasionally causing swarms of earthquakes. Scientists monitor it obsessively using GPS, seismographs, and satellite radar. Every tremor, every bulge in the ground is tracked. But here's the catch. We don't actually know what the warning signs of a super eruption look like. No human has ever witnessed one. Our only clues come from geological evidence, ash layers, lava flows, and ancient sedimentary records. Despite public fears, experts estimate the chance of Yellowstone erupting in any given year at about 1 in 730,000. Statistically small, yes, but then again, the chance of being struck by an asteroid is also small, and we still fund space programs to watch the skies. Yellowstone isn't our only concern either. There are other supervolcanoes around the world, some just as dangerous, some showing signs of increased activity, some sitting beneath populated cities. While Yellowstone might be the most well-known supervolcano, it's far from the only one. And in some cases, it's not even the one scientists are most concerned about. Across the globe, there are at least 20 known supervolcano systems. Some are ancient and quiet, with only subtle signs of activity, while others are showing unmistakable signals that something beneath the surface is shifting. One of the most unsettling among these is the Phlegraean Fields, or Campi Flegrae, in southern Italy. And unlike Yellowstone, which is surrounded mostly by open space, Campi Flegrae sits directly beneath a densely populated region, including the city of Naples, home to over 3 million people. The Phlegraean Fields aren't new to catastrophe. Around 39,000 years ago, this complex caldera system erupted in what scientists estimate to be a VEI-7 event, sending ash across the Mediterranean and Eastern Europe. Some volcanologists believe this eruption may have contributed to the extinction of Neanderthals, who were already in decline across Europe. That theory remains debated, much like the Toba bottleneck hypothesis, but it's a reminder of just how interconnected these volcanic events are with human history and human survival. Today, the Phlegraean Fields are experiencing a phenomenon known as bradycism, which refers to the gradual rise and fall of the ground due to shifting magma or hydrothermal activity. In the last several decades, the ground in the region has been rising at an accelerating pace, accompanied by swarms of small earthquakes and increased gas emissions. In 1983 and again in 2023, the Italian government raised alert levels and began formulating evacuation plans for hundreds of thousands of residents. Schools ran drills, emergency routes were mapped, and scientists from Italy's National Institute of Geophysics and Volcanology began warning that a new phase of unrest may be starting. Unlike a typical stratovolcano, where eruptions often begin with visible activity like lava or ash columns, Caldera systems like Campi Flegrei can explode without much surface warning. The danger lies in the gas-rich, viscous magma trapped beneath layers of rock. As the pressure builds, it's like a sealed pressure cooker with a faulty gauge, quiet until it's not. A VEI-7 or VEI-8 eruption from Campi Flegrei would devastate southern Italy. Pyroclastic flows, fast-moving waves of superheated gas and volcanic matter, could race across the land at hundreds of kilometers per hour. Ash clouds would spread across Europe. Flights would halt. Agricultural systems would fail under layers of ash. And unlike in ancient times, modern life depends on tightly connected global networks, communications, food trade, fuel, all of which could collapse in the wake of a super eruption. The cost wouldn't be measured in billions, but in lost decades of recovery. Moving eastward, another area that has volcanologists uneasy is the Aegean Sea, specifically the volcanic island of Santorini. Tourists visit it for the whitewashed buildings and blue domes, not realizing they're walking on the rim of a partially submerged caldera that once hosted one of the most powerful eruptions in human history. Around 1600 BCE, the Thera eruption, believed to be VEI-6 or 7, shattered the island and sent tsunamis racing across the Mediterranean. This eruption likely played a role in the decline of the Minoan civilization, one of the earliest advanced societies in Europe. The Santorini caldera is still active, and magma is accumulating beneath it. In recent decades, scientists have detected small quakes, ground uplift, and changes in water temperature in the surrounding sea, all signs that the system is alive. While a VEI-8 eruption is less likely from Santorini, the size of the caldera and its past behavior suggests that a large-scale eruption is certainly possible. Combined with the high population density around the Aegean and the fragile geopolitics of the region, even a moderate eruption could cause international chaos. Not far away in Turkey lies another lesser-known but geologically significant supervolcano candidate, the Nemrut caldera near Lake Van. It's been quiet for centuries, but shows signs of past large eruptions. In Central Asia, the massive caldera of Toba's cousin, the Awasa volcano in Ethiopia, also holds secrets buried under lake beds and old ash deposits. These places don't have the media spotlight of Yellowstone or Campi Flegrei, but that doesn't make them any less important. In fact, one of the lessons scientists emphasize is that the most dangerous volcano is often the one the public isn't paying attention to. And then we come back to South America. The Andes Mountains are riddled with volcanic systems, some of which are capable of super eruptions. One of the most notable is the Altiplano Puna volcanic complex, stretching across Chile, Bolivia, and Argentina. Here in the thin, high-altitude air lies one of the largest known magma bodies on Earth, the so-called Altiplano Puna magma body, or APMB. Detected using seismic imaging and satellite-based radar interferometry, this enormous underground chamber holds vast quantities of partially molten rock. Over the past few decades, scientists have observed unusual uplift patterns in crustal deformation in the region. In 1993, satellite data showed that part of the ground was rising steadily, over a centimeter per year, across an area of hundreds of square kilometers. This uplift has continued, with changes in thermal emissions and occasional gas releases. While there's no direct evidence of an imminent eruption, the geological conditions here are right for a future VEI-8 event. The magma is thick, rich in silica, and deep, but history tells us that pressure doesn't stay bottled forever. If this region erupted at its full potential, it could alter weather patterns across South America and create a regional crisis on a continent where many areas already struggle with food insecurity and climate volatility. Ash could reach the Amazon. Trade across the Andes would shut down. And while not as globally connected as the United States or Europe, the ripple effects would still be devastating. Meanwhile, back in the Pacific, the focus shifts to the Aleutian Arc, a volcanic chain stretching from Alaska into the Kamchatka Peninsula. This area is particularly interesting because it lies on one of the most active subduction zones on the planet, where the Pacific Plate dives beneath the North American Plate. The region is home to dozens of volcanoes, some of which have erupted in recent memory, like Mount Redoubt and Mount Augustine. But beneath these known peaks are deeper systems that could harbor the potential for super eruptive behavior. Scientists from the USGS and other agencies routinely monitor these areas using satellite data, thermal imaging, and seismic instruments. But even with modern tools, predicting a super eruption is incredibly difficult. Unlike hurricanes or tornadoes, volcanoes don't follow strict seasonal patterns. A volcano that's silent for 50,000 years can erupt in a week, or it might stay dormant for another 100,000 years. The challenge is that the signals are often ambiguous. Is ground uplift just tectonic motion? Are small earthquakes just crustal adjustments? Or are they magma rising? In many cases, it's only in hindsight that the warning signs become clear. Even more worrying is the fact that we've only mapped a fraction of the Earth's crust in sufficient detail. Underneath Antarctica, for example, scientists have found evidence of hidden volcanic systems buried beneath kilometers of ice. In 2017, researchers announced the discovery of over 90 unknown volcanoes in West Antarctica alone. If any of these calderas hold enough magma and were to erupt in a VEI 7 or 8 event, the consequences wouldn't just be volcanic, they'd be glacial. Eruptions beneath ice can trigger sudden meltwater floods, destabilize ice shelves, and accelerate sea level rise globally. This intersection of volcanic activity and climate instability is increasingly becoming a concern, because it's not just the eruption that matters, it's where it happens and what systems it interacts with. A supervolcano beneath a rainforest affects carbon cycles. A supervolcano beneath ice affects ocean circulation, and each of these systems, once thrown off balance, can spiral into long-term planetary consequences. The bottom line? These supervolcanoes don't erupt often, but when they do, they reset the global clock. Entire ecosystems vanish, civilizations fall, the sky dims. And while we like to think of ourselves as technologically advanced and resilient, the truth is we're still just one eruption away from crisis. The threat of a super eruption might seem distant, perhaps even abstract. It's a reality that, although rare, is ever present in the background of our planet's geologic life cycle. We've explored some of the most active and dangerous volcanoes around the world. But the truth is, the most frightening aspect of these calderas is their unpredictability. We may not see it coming until it's too late. It's important to remember that supervolcanoes aren't simply just bigger versions of your average volcano. Their eruptions, should they occur, would unleash more than just lava and ash. A single eruption could launch thousands of cubic kilometers of volcanic ash into the atmosphere, along with vast quantities of sulfur dioxide and other aerosols. These particles would form a global veil that blocks sunlight, causing temperatures to plummet, a phenomenon known as a volcanic winter. During this period, global temperatures could drop by several degrees, triggering a worldwide agricultural collapse and food shortages. Imagine the dust from the eruption blocking out the sun for years, leading to crop failures and famine across multiple continents. The aftermath of a super eruption would lead to societal and economic chaos. Entire countries might struggle to feed their populations, and political instability could spread. Governments would be overwhelmed with the challenge of managing mass evacuations, re-establishing food supplies, and responding to the sudden onset of global cooling. A perfect example of how quickly things could spiral out of control can be found in the eruption of Mount Pinatubo in 1991. While far smaller than a VEI-8 super eruption, Pinatubo's eruption still released an enormous amount of ash and sulfur dioxide into the atmosphere. In the months following the eruption, global temperatures dropped by about half a degree Celsius, enough to disrupt global weather patterns and, in some regions, crop production. Imagine this effect being amplified and lasting for several years instead of a few months. This would likely be the scenario in the aftermath of a supervolcano eruption. One of the most unsettling facts about supervolcanoes is that we cannot predict when the next one will erupt. And many of these volcanoes are located in places where the risk is not immediately apparent. The supervolcanoes we've discussed in this video, from Yellowstone to Phlegraean Fields, are being actively monitored by teams of geologists and volcanologists. Yet even with modern technology, the indicators for a potential eruption remain cryptic and elusive. Ground uplift, increased seismic activity, or gas emissions are all signs that an eruption could be coming, but they are often only noticeable in the early stages of volcanic unrest. And by the time these signs are clear enough for widespread alarm, it might already be too late to take effective countermeasures. That said, it's not all doom and gloom. One of the most powerful tools we have in mitigating the impact of a potential supereruption is science. Over the last few decades, scientists have made significant strides in monitoring volcanic systems. Today, we have the technology to observe ground movement, gas emissions, and seismic activity with incredible precision. Satellite data, seismic sensors, and thermal imaging allow scientists to track the movement of magma beneath the surface, providing early warnings of potential volcanic activity. One of the most advanced monitoring systems is the Yellowstone Volcano Observatory. It continuously tracks seismic activity, ground deformation, and gas emissions from Yellowstone and its surrounding areas. And while it's true that the odds of a super eruption at Yellowstone happening in our lifetimes are extremely low, the ongoing monitoring efforts are essential in ensuring that scientists can detect any early signs of unrest. In the case of Yellowstone, scientists are particularly interested in the region's famous hot springs, fumaroles, and geysers. These features release gases and steam from deep within the earth, providing clues to what's happening below the surface. When gas emissions increase or the ground shifts unexpectedly, scientists use that data to assess the risk of an eruption. Monitoring these warning signs and understanding volcanic systems is essential not only for predicting eruptions, but also for developing better evacuation strategies. Today, we have sophisticated models that can predict the direction of ashfall, the distribution of pyroclastic flows, and even the impact on climate. Governments and emergency management agencies around the world have contingency plans for volcanic disasters, and they work closely with scientists to keep the public informed and prepared. In the case of a supervolcano eruption, the key will be how quickly authorities can act to relocate people and distribute resources. While this would be an enormous logistical challenge, it would be less about saving people from the eruption itself and more about saving them from the long-term effects of the eruption, particularly the ensuing global cooling and food shortages. But the big question remains, how much time would we have? If a super eruption were to occur, could we evacuate hundreds of millions of people in time? Could we develop and distribute food supplies for an entire planet grappling with crop failures and harsh temperatures? The unfortunate answer is that there is no way to know for sure. As of now, we simply don't have a foolproof plan to respond to the global scale of a supervolcanic eruption. The best we can do is monitor, prepare, and hope that the next super eruption remains just beyond the horizon. It's important to note, however, that the likelihood of a supervolcano erupting in our lifetime is extremely low. The chances of Yellowstone, for example, erupting are estimated to be around 1 in 730,000 per year. However, as history has shown, these eruptions are not predictable in terms of timing. They occur on geological timescales, and while the risk may be low, the potential consequences are catastrophic enough to warrant ongoing study and vigilance. What's most fascinating about supervolcanoes is that they also serve as time capsules of Earth's past. By studying ancient supereruptions, scientists can gain insights into the Earth's volcanic history, its climate cycles, and the ways in which life has responded to catastrophic events. The Toba eruption, for example, offers us a glimpse into the resilience of human beings, showing that humanity endured despite the severe climate disruptions it caused. It's a reminder that while nature can reshape the world, life, especially human life, has a remarkable ability to adapt. In the future, as our understanding of these supervolcanoes deepens, so too will our ability to predict and prepare for them. The challenge will always be one of time. How much notice can we get before a catastrophic eruption occurs? In the coming decades, advances in geophysics, seismology, and satellite technology will continue to improve our ability to monitor these volcanic hotspots. Hopefully by then, we will be better equipped to respond and prevent global-scale disasters.